We now proceed to study an example of a One Health TV application or projection. If we followed the steps outlined in the One Health sessions and created a new One Health projection, you will find an interface that looks something like this. The first thing to discuss is the version of the software. We are currently on version 6.07, beta 4, which contains the latest changes to the time model. The One Health information we'll be studying reside in health services. The impact model modules tab lists all the disease models we will be using. It lists here the demographical model, the HIV model that UNH uses every year to produce HIV burden estimates, and of course, the time model, which comprises time estimates and time impact. This information is also arranged in the program manager. Here we set the name of the projection. I have simply called it country X. We also set the first year and the final year, which correspond to the first and final year of the plan to be costed. While the final year can be extended after the creation of the projection, it is generally not recommended to do that, but rather to set it correctly from the start. The One Health modules are configured here in the One Health tab. I will not go into detail here. Here is where the impact modules are configured. So we have the demographical model, which is always active for all of the other health models because it provides the basic demographical model for the other models to use. If the time model is active, the HIV model will always be active too because it provides the HIV information that is used by the time model. And of course, here we have the time model checked. In some One Health costing applications, one might also be interested in family planning programs, child health programs, malaria programs, sexually transmitted diseases, non-communicable diseases. But for this example, I simply want to look at the time model. And also it would save processing time to ignore the other complicated models for now. An important area is the default data. Here we select the country whose default data we want to base the projection on. I've already selected Myanmar when I created this file. If I reselect these checkboxes, it would reload the default data of either demography, AIM, or TB. The user has to be careful when revisiting this editor, and for example, selecting this checkbox would reload the default data. Now, if that data has been edited, it will simply be replaced by the default data. So the user should be careful when replacing this data. Now I will exit the program manager and go to the time estimates model. As I've mentioned, time comprises of the time estimates and time impact, and we will be studying time estimates. In general, in the One Health tool and in Spectrum, information is arranged from left to right. The user first starts at the leftmost tabs and works through the tabs from left to right towards looking at results. The first thing to look at is the configuration. And here the most important thing is the final year of statistical projection. This year will typically be before the final year of the projection, which was discussed moments ago. And it is recommended that the user adopts an approach of only a few years of statistical projection. 3 to 5 years is recommended. Something longer than 5 years typically does not produce a reliable statistical projection because the assumptions that are needed for long-term projection of statistical models typically don't hold. So we recommend that the final year is only a few years after the first year. And in this tab, there are configurations related to the target populations, which we will discuss in some detail later on. Much of the user's review work will be in the program statistics area. This is a series of editors that arranges default data for different aspects of TB. So we have data related to TB incidence, that we get from the WHO databases. We have data for one data point for TB prevalence. The WHO is not publishing this data anymore, but we still use this data point for some purposes. The most important tab here is the TB notification data, because here the user will configure how TB notification splits into different case types. And these different case types form the basis of costing work in One Health, as explained in the course guidance document, and as I will also explain in some detail shortly. We also have information related to HIV TB burden, so data that's come from surveys or sentinel HIV settings or routine TB testing. There is a tab where the drug-resistant data is arranged. We have to define or review the resistance burden, case detection, and treatment initiation. All of those are elements related to the costing of drug-resistant TB. A new editor in the current version of the software is the TB preventive therapy section. Here the user can arrange and configure data for TPT in 3 areas, either in households, high-risk groups, and ART patients within ART cohorts. And within each one of these, the user has to configure the characteristics of the population with respect to latent TB, active TB, and population size. We will return to this issue. Similarly, in high-risk groups, one has to define the size of the population as well as the prevalence of active and latent TB in children and adults. And likewise, in the ART cohort, we have to define the prevalence of latent and active TB. Here we do not need to define the size of the population because that information comes from the HIV model that is prepared by the country for UNAIDS, and we use that information directly here. So the user does not have to, within the time estimates model, configure that information directly. However, the user can go into the AIM model and look at each program statistics where information about ART, for example, is specified and prepared by a country team, typically. Returning to the estimates model, once the program statistics have been reviewed, the user can proceed to study this simple tab here called Epidemiology. Here we define the case fatality ratios that is applied to non-notified cases and notified cases. Of course, notified cases have a lower case fatality, and we define this in different categories depending on HIV status and also on whether the case is receiving, the HIV positive case is receiving ART for less than 1 year or more than 1 year, because again, the case fatality ratios really differ over those periods. We'll return to this editor as well. Then the user, this is the interface where the user deals with fitting of the model. This will be discussed in detail too. Once the user has fitted the models, he can study the fits through the data. Now the user will notice that we already have default projections through the data. That is because the database for each country is loaded with default forward projections that are used for many reasons, such as global studies of TB burden. However, we do recommend that the user go through the model fitting process and not use these default curves, because typically the user can produce a better fit than is produced by default. The reason for this is simply that when the user configures the fitting parameters for each country, he can produce more reliable confidence intervals by generating more statistical samples that are used for the uncertainty intervals. But when it is produced for global analysis purposes, it has to be restricted. Otherwise, the process will take too long to complete, since it has to run for 170 countries. The area here called policy goals is where the user can set an overall notification target. So the user may define an increase in notification, which is constrained by total incidence, meaning that the user cannot set a notification target that exceeds the projected TV incidence value at the final year of the projection. And returning now to the case fatality ratios, if more cases are notified, then more cases will be subjected to a lower case fatality ratio, and that is the basis of calculating the impact on mortality, an issue that we will return to. Finally, when all these steps have been completed, the user can view results, for example, generate curves for incidence or for notification mortality. The user can study the latent TB section, which is really just a reflection of the data that the user provided. There are detailed epidemiological summaries as well as impact summaries, and most importantly is a fairly comprehensive one of target population. I will not generate that population at this point because it takes time, and this purpose of this session was simply to provide an overview that I will conclude shortly. I just want to mention briefly the time impact model, which we will also study. The big distinction between the estimates model and the impact model goes back to the fitting of the model. The time estimates model is based on a cubic spline fitting technique, which uses a number of statistical parameters to fit the model. But those parameters are not linked directly to interventions, which means that the statistical projections of TB burden don't reflect explicitly changes in TB interventions, and therefore its projection of impact of interventions is very limited. The time impact model, however, is a dynamical model which goes in detail into the natural history of TB and also into the nature of TB interventions, which are explicitly modeled, and therefore it can be used to study the impact of many types of interventions in great detail. That is just a short remark on the distinction between the two models, and for this course we will work strictly with the time estimates model. This concludes the overall introduction into time estimates. Just providing an overview, we will now go into some detail into session 2, which is about objective 2, which is about configuring the program statistics, reviewing and configuring the program statistics.